Level 2 for Python, where today we'll be learning about conditional flow constructs. So the learning objectives for this module are to construct logic operations to generate control flow statements, and we're going to learn how to create conditional statements and structures in Python so that we can use them to develop Python scripts that solve problems that require different sets of actions that depend on the user inputs. So previously in sequential flow, we could only do inputs that would operate one after the other, but now we can run the program depending on the inputs by the person. So with the sequential flow algorithm, you're limited to a single course of action. Suppose we wanted to develop an algorithm where we would determine whether a solution was acidic, basic, or neutral based on the pH of the solution, where the pH was an input given by the user, we would not be able to do so. So this could not be done by a sequential algorithm, but it can be done by a conditional algorithm. So with the conditional flow algorithm, we have the options to ask the user for inputs, and the user can then tell us, hey, the pH is 7, then the solution would be neutral. If the pH is greater than 7, solution would be basic. If the pH is less than 7, the solution would be acidic. So the first step in implementing a conditional flow algorithm is creating a conditional statement. So a conditional statement is a statement which has a simple yes or no answer. Oftentimes, yes or no is also replaced by true or false. For example, is one number larger than the other? Does the word exist in a sentence? Yes, like any sentence. Does coffee like lasagna? The answer is yes or true. And a conditional statement utilizes different operators to create the logic. Usually we use logic operators and relational operators. Now let's talk about relational operators. Relational operators in Python are used to compare um, relations between two things. So to check if two things are equal, we use two equal to signs. Not equal, we use the exclamation point and equal to sign. Less than, we use the crocodile sign. And then we have greater than or equal to, and so on. So the logical operators are how we combine relational statements in order to create more complicated conditional statements. So this is like saying, is the pH greater than 5 and is the solution orange juice? So that's just an example, but we could say if the pH is greater than 5 and the solution is orange juice, output it's acidic orange juice. So for that we use and or and not operators in Python, which is shown here. So the and operator is only true when both are true and is false in every other case. The or operator is true if any single A or B is true. And not is just the opposite. So if it's true, then you would get false. If it's false, then you would get true, and so on. So the Python syntax for these operators is to use lowercase and, or, and not. Python, we have three different types of conditional structures. The first type of conditional structure is an if conditional structure. So in an if conditional structure, it has the capability to perform a set of actions or not. So we ask a question, and if the answer is yes, then we perform a certain set of actions. If the answer is no, we move on to the rest of the algorithm. So the Python syntax for this is if condition followed by a colon, and then the Python commands to execute if the condition is true. Now, something that programmers often forget is to include the colon. So it's very important that you don't forget the colon. And everything below this is indented in Python. Indentation is important in Python, and it's basically four spaces or a tab space here. And everything that's indented under the if condition will be executed if the condition is true. Now, the second type of conditional structure is an if-else structure. So an if-else structure performs one set of actions if the condition is true. So if the question that we ask here answer is yes, then we would perform action 1. If it's no, we perform action 2. Otherwise, we'd perform, and then we would move on to the rest of the algorithm. The Python syntax for this is if condition is true, then these are the commands to execute. If the condition is true, and else, and if it's else, then these are the commands to execute if the condition is false. So something to notice here is that if has condition, while else does not have a condition. So this means if this condition is false, then regardless of what it is, else will be executed. So the keyword follow else is always terminated with a colon, just like if. Python commands to be completed if the condition and false are included below the else statement, and they must all be indented properly. So the third type of conditional structure is a nested if structure. So this is a structure which has multiple pathways. So as you can see in this flow diagram, if we ask it question 1 and the answer is yes, then we execute actions 1. But if the answer is no, then we ask it another question. And if the answer is yes to that question, question 2, then we execute actions 2. But if the answer is also no, we keep moving on until we get to a point where the question is either a no, the answer is either a yes or no, and then we can move on to the rest of the algorithm. So the Python syntax for this is start with an if statement and the first condition followed by colon and then the commands under that. And then the rest of the commands are used with elif. So this is a keyword elif, which basically means else if. So if this is not true, then else if. So try these other conditions. And these are the conditions to execute if these conditions are true. So this would mean elif condition 2 would mean execute if condition 2 is true and condition 1 is false. Elif condition 3 would mean execute condition 3 if condition 1 and condition 2 are false and condition 3 is true. And then else would be when all of these conditions are false, then execute what comes under else. On to our first example problem that's going to involve some live coding. So the first example problem is we have to create a Python script that will determine an output whether to buy a stock, sell a stock, or hold a stock. So as we talked about it, the output is to buy, sell, or hold. The input is the current price of stock, and here's what the processing looks like. So if the price is greater than $75, we want to sell the stock. If the price is greater than 65 but lesser than or equal to 75, we hold the stock. And if the price is lesser than or equal to $65, we buy the stock. So let's look at what the flowchart looks like for this problem before we move on to coding. So we start the program, we input price, so we take in an input from the user. And then the first question we ask it is the price greater than $75? And if it's true, then we output sell the stock, we end the program. If it's false, then we ask it, is the price greater than $65? So if the price is greater than $65, and if this is false, that would mean the price lies between 65 and 75. So if it's true, we output hold the stock, we end the program. And if that is also false, that would mean that the price is lesser than or equal to $65. So then we output buy more stock and we end the program. So if you notice, this is actually of the form of a nested if structure, which is what we're gonna discuss now while coding. Problem 1. So I've written the logic down here so we don't have to refer back to the problem. So the first thing we need to do is take price from the user. So we can create a variable price, and then it can be a float or integer, but we're gonna assume it's a float because it's stock, and stock values have decimal numbers. So we're gonna say it's float. We're gonna say input, enter the current price of the stock. So that is our price. And now we're going to start with the if statement. So the first statement would be an if statement, and we're going to say if it's greater than 75, print sell the stock. So if price is greater than 75. So notice how this is the condition. So we're saying if price is greater than 75, put the colon, sell the stock. So we'll print sell the stock. So you notice that this is the indentation, which is 4 spaces, which makes sure that if the price is greater than 75, then this is what we printed. Then we do elif, since we know that we want the price to be between 65 and 75, we can say if elif price is greater than 65, print hold the stock. So this is a form of nested if that we talked about before. So we have if this, so elif price is greater than 65 means price was not greater than 75, and price is greater than 65, then hold the stock. And then else is if both of these are false, which would mean that the price is less than or equal to $65, then we can print buy more stock. So that's pretty much it for the program. And now we can actually run this. So if we run the current script, code for this problem written, we can actually run the program itself. And as we see, it asks for the current price of stock. We can do $80. So this should give us sell the stock. And it did, it says sell the stock. Now let's do a value between 75 and 65. If you do $70, it should give us hold the stock. And it did, it gave us hold the stock. So our code is working, that's good. And then if you do a price less than or equal to 65, so if you did $50, then it's going to say buy more stock. Now how about when it's equal to $75? So if it's equal to $75, it's going to say hold the stock, because you know if it's greater than 65, it's going to say hold the stock. And then if you do 65 itself, it's going to say buy more stock, because that would mean the price is less than or equal to 65, so it would buy more stock. So that's the example problem 1. example problem for Python conditionals. So this example problem says, hey, let's create a Python script that converts and outputs a temperature that is in either Fahrenheit or Celsius to Kelvin. So the output should be a temperature in Kelvin. The input should be a temperature that has to be converted and its units. So it will be a value, number, and then if the units are in Celsius or Fahrenheit. And then the formula that they've given us is if you want to convert Celsius to Kelvin, you add 273.15. And if you want to convert Fahrenheit to Kelvin, you do 5 by 9 multiplied with the temperature minus 32 plus 273.15. So now let's look at the flow diagram for this problem. So this might look complicated, but it's actually very simple if you think about it. So first we're going to start the problem. We're going to take the input from the user. We're going to take the temperature, which is the value, and then we're going to take input in units, which would be C for Celsius or F for Fahrenheit. First of all, we're going to check if the units are valid. So if the units are C or Fahrenheit, only then will we proceed with the rest of the program. So if the units are not C or F, we're going to say, hey, it's an error. Units must be either C or F. We're going to straight up end the program. Otherwise, if the units are C or F, then we're going to say it's true. If the units are C, we're going to ask it, are the units C? If the units are true, then if the units are C, then we're going to do temperature plus 273.15, and we're going to output that temperature. If the units are not C, that would mean the units are Fahrenheit. Then we would do the other formula, which is 5 by 9 times temperature minus 32 plus 273.15, output the temperature, and end the program. So very simple logic. So now let's get to implementing it in Python. Example problem 2. And we're going to first take the temperature as an input. So we're going to do temp equal to float input enter temperature. So that will be the temperature that the user gives us, and then we're going to do unit. So unit is going to be a string, so we're not going to do float or enter anything. We're just going to do a basic input, because remember that the default in Python when we do input is a string. So we're going to do enter units of either Celsius or Fahrenheit. So now the user will give us units, and first of all, we're going to check if the units are Celsius or Fahrenheit. Otherwise, output error. So what we do, if unit equal to Celsius or unit equal to Fahrenheit. Now, as discussed previously, to compare if something is equal to, we use double equal to signs in Python, so this will check if the unit is either Celsius or Fahrenheit. And if it is, then we're going to run the rest of the code. So I'm just going to leave a comment here. But before that, if it's not, if this is not true, then we want it to output if it's false. If it's false, then we want it to output error. So we can do print error, exclamation point, units are incorrect. Please enter C or F. So that's our error. So now let's get on with the rest of the code. So the rest of the code, we're going to do if unit equals C. What format do we use? Oops, look, I made an error here, so we can do some live debugging. We actually have to do two equal to signs, because if you do if unit is equal to C, it will give us an error. Like, look, it says syntax error, invalid syntax, so we have to use two equal to signs. So if unit is equal to C, we're going to use the formula that they give us, which is temperature is equal to temperature plus 273.15. And then we're going to just output that temperature. So we're going to print temperature in Kelvin equal to, and then we're going to do this to 3 decimal places. So this is the syntax for that. And then we're going to output a new line. And we're going to say format temperature. So this is a syntax. So whatever you have in the curly brackets, you're going to output like that. So we're saying it's a float and we want it to 3 decimal places. So this means up to 3 decimal places. And then whatever is in the curly brackets, we format. So we're saying the temperatures of that format. Now we do the same thing for Fahrenheit. So if the unit is not C, that would mean the unit is F. So then we do the formula, which is temperature is 5 by 9 into temperature minus 32 plus 273.15. And then I would do the same thing again, except this time it would be temperature in Kelvin. Actually, no, it would be the exact same. So this would be the exact same. So that is our code. Now let's run it and see how it runs. So now it's giving us a temperature. I can do 15 and I can do C. So now it gave us a temperature. Another thing that we can do is we can add Kelvin here. So we can do K, run it again. Let's say we do 30 this time. We do Celsius. So this means it's 303.150 Kelvin, or K. If we do the same thing with Fahrenheit, we get 272.039 Kelvin. So this way we have done example 2, which was a nested if structure with an if structure inside another if structure. The module. The focus of this module was creating conditional structures in Python, and as we've seen through the examples and the live coding sessions, we can see that how conditional structures can help in developing algorithms and programs that solve problems by allowing user input and dictating our actions to the user input. And we can do this through various ways. We can do it through a nested if, we can do it through if else or if else conditional structures and so on. I hope you guys enjoyed this module and it helps you understand how if statements and conditional statements work in Python. Thank you for watching.